Hello, welcome to my tutorial. Today we are going to solve the transitive closure problem of a graph. So the question is given on the GFG. So let's read the question first. Given a directed graph, determine whether a vertex j is reachable from another vertex I for all vertex pairs ij in the given graph. Here vertex j is reachable from another vertex I means that there is a path from vertex I to j. The reachability matrix is called the transitive closure of a graph. The directed graph is represented by an adjacency matrix where there are n vertices. So we have already studied about the transitive closure of a graph and we already know the algorithm. And for the algorithm, please check the previous video. So we implemented today. So we are given with the 2D matrix graph and we have to find the transitive closure of the graph. So let's first declare a 2D vector. So we have declared the 2D vector t and of size n cross n and we have initialized it to 0. So now we will use the two for loops for traversing the graph. Okay. In these two for loops, we are traversing the matrix graph, and if there is entry, uh, suppose graph ij is 1, it means that there is an edge from vertex I to vertex j. So therefore, there exists a path from vertex I to vertex j. So according to this condition, we will modify our matrix T. If there is an edge from vertex I to vertex j, then we can say that there exists a path from vertex I to vertex j. It's an obvious thing. So therefore, we have set the Tij to 1. Now we will use the three for loops. Now the first for loop is used to find the intermediate vertex k such that there exists a path from I to k and there also exists a path from k to j. In that case, we can say that there exists a path from I to j. So we will write this condition. So in this statement, what we are doing is we are first checking whether there exists a path from I to k and k to j. Uh, if there exist these two paths, then we can say that there exists a path from I to j. And if we are unable to find such k, in that case, we will remain the entry Tij as it is. So now let's return the 2D matrix T. So we are getting wrong output here. In the input, we can see that all entries are 0. It means that there is not a single edge in the graph. But in the correct output, we can see that the entries in the principal diagonal is 1. It means that according to the output, all the nodes are reachable from itself. So in this question, it is assumed that the node is reachable from itself. So we have to incorporate this condition also. To incorporate this, we have to modify our if condition. Okay. In this, I have added this condition I is equal to j. If the starting vertex and ending vertex is same, then there exists a path from I to j. Now let's try to run it again. We are getting the right output. So thank you. Stay tuned for more updates.